So, okay, so this is the review for exam one for, oh goodness gracious, what, we're summer semester 2019? Wow, time flies when you're having fun. So obviously this is the exam we gave for fall of 2017. I had to go back a ways to get one that was doable. I didn't have this class last semester, didn't have enough students, they canceled it on me. Well, they canceled the 10:30. I had the 10:40. Well, I guess I could have gotten. Oh well, it's too late. I already got this one. Sorry. I guess the only one I wouldn't have would be the final for 10:30. Anyway, I tend to go off on tangents quite a bit. So anyway, in the testing center, you will need to uh, schedule an appointment to take the exam with the testing center. Do not show up without an appointment. You will have 2 hours after the exam is open on your computer. They will give you the exam on a thumb drive. Um, it's kind of wishy-washy. Um, if you can work with it on the thumb drive, I would suggest that. Make sure you save often. If not, save it to the computer. But that's kind of scary, because if those computers in the testing center get turned off for any reason, they wipe the hard drives clean and you'll lose everything that's on the hard drive. So you're better off to change the current directory. You can do that by clicking this button up here and navigating to the thumb drive to set that as your current folder and leave the data on the thumb drive, unless the testing center tells you otherwise. Um, I've had a few students come up at the end of the test saying, I've lost everything because the computer crashed, and the only option I have is to have you take the test again. So that's your choice, I guess. It will be in the Live Editor format. If you do not like Live Editor, you can take this and go up on the editor sheet, Live Editor sheet, go do a save as, and then change the format down here to an M file, and it will create an M file of the same document. But I would prefer you stay in here if you can. If not, I'll end up converting it back to Live Editor anyway, because one thing I like about the Live Editor when I'm grading is I'll re-execute all of your code, and you can see exactly what I see when I'm grading it, for better or worse. So it will be open book only for the MATLAB portions. The testing center will provide you with an electronic copy of the textbook for which you can use. No notes, no old homework in either hard copy or electronic format. No neighbors, no psychic abilities, no network, no internet. Just you and the notes. You can use the help feature that is built into MATLAB. If you haven't had the opportunity to use that yet, that is just over here. You just type in the word help followed by the command, uh, and hit enter, and it will give you what data it has for help on that command. And if that's not enough for you, down at the bottom there's also a reference page that will open up a browser window and give you even more detail on the command. Those you may use during the exam. Um, Bing Bonk, hello, welcome. Okay, so I think that's all I have for that. This this exam is next week. I think you have Monday through Friday in which to take the exam. I think it's exam two where they cut the last day off because they were doing some training or something at the testing center, and they didn't want to disrupt the students, so they just cut me off on Thursday. Um, okay, well, so anyway, this is the exam that was given, first exam for fall of 2017. I will go through and work the problems for you, how I would do them. Now, I tend to get carried away sometimes with the output. It is not required that you get all fancy like I do. Um, some of the stuff I try to, for me, it's hard to remember which part of the textbook some of the stuff I know how to do came from. So I may do some things from the fact, even on one of the exams, on exam one, I put stuff in that wasn't covered until exam two. It will include up to and including the chapter on user defined functions, which I believe is chapter 6. So if I go too fast, holler, tell me to slow down, stop. Feel free to ask questions. I'll move this chat window back down here. This should show up in the video too, and it'll help me so I can see your questions come in. So, I haven't seen exam 1 yet, so I don't know what it looks like. There are 2 of us teaching this course this semester. The other instructor will be writing exams 1 and 2, and I'll be doing both of the finals. Yay! Yeah. So hopefully he gets it to me before Monday. So anyway, okay, so this exam here, problem 1 is worth 10 points. And then it breaks it down into how much each part is worth. So B is 4. So if you get stuck for a long time on something that's only worth 2 points, skip it. Don't lose all these points down here because you couldn't figure out how to do this 2-point part. That's just me speaking out weirdly. Okay, so an engineer measures the diameter and lengths of a number of steel rods. The measured data is given in the file named rods_data.dat. The first column indicates the item number of the rods. The second and third indicates the diameters and lengths of the rods respectively. Part A, 4 points. Load the import. Use the load function, import the data. Note, if you can't do this part, copy and paste the data into the file. You will lose points for this part. But so basically that says if you don't know how to use the load command, just copy it into the data file. You will not receive the 4 points for using the load command, but you'll have the data for parts B and C. But to use the load command, we just type in load. The name of the file was rods_data .dat. And is this file already in here? I hope. No. Where was it? Oh, I know where I was. Sorry. I know I copied it over so it'd be here for this test, but I think I was over here in the downloads because that's where I was working last. Yep, there it is. rods.dat. So that is very important, that the data file needs to be in your current folder. If it's not, you will get an error. I guess I should have showed you what happens. See, so if we run this code here now, you're going to get an error. Oh no, you're not going to get an error because I have mine defaulting back to a folder where I keep all the data files in case students don't. But if it's not in your current folder, you'll get an error, and that's because you're not. So you're best to make sure that the current folder has a copy of the data file. Okay, so that was easy. 4 points for all those little letters. Part B, okay, and if you're running the script file and you notice that this here isn't executable section here, you can just come up here and hit this code button, and now you can type code. Calculate the cross-sectional area and total volume of the rods. Oh man, you're wanting me to remember how to use that stuff? Oh, okay, and then down. Okay, here's. Okay, so I think the diameters was in column 2 and the lengths were in column 3. So we'll do diameters equals. Let's make this easier for me to type. No whys. Come on, you can do this. You know how. Data equals. Okay, so it loaded it into a variable called rods_data, and that's a lot of typing for me. So I shorten it down to something simple with an F. That's my grade on the exam. Okay, so we want all of the data from column 2 to be our diameters, and then the lengths is going to be all of the data from column 3. And if you guys see me make an error, by all means speak up, scream at me, yell at me, say, hey stupid, that's not right. And oh, look at that. Oh, that was where I was demonstrating. Okay, that's not supposed to be there. Okay, so here we loaded them. Now let's calculate the cross-sectional area. The cross-sectional area is equal to pi times the radius, and we'll have to use the element operator because there's more than one diameter squared. So there's the cross-sectional area, and then the volume is going to equal the cross-sectional area times the length. Again, we need to use the element operator because they're both vectors, times the length. No L's. Commas. And report the answer using the correct number of significant digits. You know what? I don't know that we've taught significant digits in this class, this point. Report the answer. And report the answer using the correct. Okay, well, we haven't taught that, so I don't think I graded that. Again, this is an exam I didn't write. So if we put this into a table now of our data, equals, we're gonna have we have our numbers. So we have the number of our thingies is going to be all of them in column 1, and then oops, not there, and then we'll put our cross-sectional area followed by our volume and pray that this works. Boom, and it should give me a nice little, what? It's right there. Don't give me that. Oh, maybe I gotta run this one first. There you go, stupid. Sorry. You gotta run the one where the data loads. Okay, so here's our element number, here's the cross-sectional area, and here's the volume from each. Any questions? Okay, cool. So, and then put your results in an array with the number in the first column, cross-section. Oh, look at that. I did part B up here, part C up here. Okay. The table, or this exam, obviously is not organized very well. I'll make sure that the exam is organized right before you guys get to it. I mean, it shouldn't ask you to do part C up here in part B and then tell you to do it again down here in part C. That's just pure lunacy. And you'll be sitting there at your computer thinking, why? What's the difference? What is it? And you'll spend an hour and a half trying to figure out what's going on there, and then the rest of the test goes empty. Okay. So anyway, I have to make a disclaimer here. I'm very, 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 very tired, and I get kind of loopy when I'm tired. So just a forewarning. Okay. The capacitance of any questions on part 1? Pretty easy, pretty straightforward. Okay. Question number 2. Capacitance, two parallel conductors of length L and radius R separated by distance D, and air is given by C equals pi epsilon L natural log of D minus R divided by R, not necessarily MATLAB code, where epsilon is the permittivity of the air. Right, MATLAB code to calculate the capacitance for L equals 1. Okay, and we're going to cheat and borrow these guys here and bring them down here. And that equals that, and D equals that, and M and epsilon. Oh, M was up here for units. Okay, that's what you call creative cheating, so that I make sure I get the numbers correct. I have a problem with dropping digits when I'm okay. So we got pi, we got epsilon, d, r. Okay, so hey, that's pretty cool. So this is not necessarily MATLAB code, but that doesn't mean we can't borrow it. So anybody know what the natural log command is in MATLAB? You're right, it's the log. And that should be everybody. I mean, we can put some brackets around here to make it cleaner, but it doesn't matter. It's all hunky and dory, and there we go. C equals 2.539 times 10 to the negative 11. So that's a simple problem of just plugging in variable name numbers and writing an equation. Okay, problem number 3. The following table gives data for distance traveled along 5 truck routes and the corresponding time required to traverse each route. Oh, I remember this problem. This one was a silly problem. I think I got it wrong when I was making the key for it too. So, okay. Use the data to calculate the average speed required to drive each route. Okay, so if we have the distance and the time, the average speed would be finding the speed for each of them and then taking the average of it. So if we have up here, we have our routes. Okay, so we have 1 through 5. That one's easy to do. We can just do it that way. Oh no, somebody's making noise on me. Hang on a second, it might be important. I got a child who's having issues. Okay, so, and then our distance traveled is going to be 560, 440, 490, 530, 370. And you notice I put a semicolon at the end of each of my defining variables, just so it doesn't print them out. That's all I'm interested in as a final answer. And then time is going to equal 10.3, 8.2s, 9.1s, 10.1s, and 7.5s. So now it wants the average speed or velocity. So the velocity is equal to distance divided by time. Time with an M. And then if we want the average of that, the average, come on, you can hit the right key. There it is. Average velocity is going to be the average of our velocity. Boom. Oh, that's not supposed to be a minus sign. That's supposed to be an equal sign. So the average velocity is 52.7364 units per time. Oh, miles per hour. Okay, so that gives us the velocity, and now we can go to part B. Part B, find the route that has the highest average speed. In order to earn credit for this problem, you must use MATLAB to determine which route corresponds to the highest speed. You may not just look at the results and pick out the number, either for the maximum or the route number. Okay, so this is, oh look, here's where he wanted to put the solutions. That's okay. I don't take off points if you put your solution somewhere different than what we specify. So we are going to use the max function, and if we assigned the um, output of the max, um, come on, you can say, you can think and type at the same time. No, I can't. I can't chew bubblegum and speak. If we put the output of the max to two variables, um, it will return the maximum value in that vector and the location within the vector. So now we know what the maximum velocity is and where it's located. So to find, what are we supposed to, average speed, find the route that has it. Okay, so so our route max speed we get by going back to our route numbers. Did I capitalize my routes? I didn't. And find out which route is in the same location as our um, maximum speed, and that will report back the route number. Boom, and it was route number 1. And if we looked at the velocity, we would see then that it is indeed the first one is the highest velocity. Okay, any questions on that? I know we had a couple assignments on there. Most of you got that right. Some of you struggled a bit with it. Okay. Next problem, problem 4 is create a vector x of the values 1 to 5, 1 to 5 in the increment of 0.2. That was an easy problem. Part B, x y1 that results from the function y1 equals 7 sine of, I'm guessing, x. Oh, 4x. Ooh, see, good thing I looked at that. Is equal to 4 times, who stole my times button, x. And we're going to hide the output on these because I have a feeling we're going to plot them. Number 3, determine the number of elements in the array y1. Okay, elements, and that's just let's see, that gives us one by, let's do length of y1. We'll leave that one out because we want to see the output from that. Determine the value in the third element of y1. Okay, third element equals y1 and the third one. So there are 21 elements, and the third element is minus 6313. Okay, any questions on those problems? Generally, when I write my exam, they're already in there, but yes, that is a very good point. You should get in the habit of clearing out your variables between each problem, because if I had done something, yeah, I've seen people that, they're down here working on problem 5 using variables created in 1, and things aren't working right and they don't know what's going on. So yes, viewer 4, that is a very good point. Definitely you should clear all your variables. However, when I write the exams, I try to put clear and CLC at the beginning of each problem. But again, I didn't write this exam, so, but good catch there. However, on problem 5, you don't want to do that because you're going to use the values from the previous problem. So, okay. Okay, so in previous problem, you created a vector x of values from 1 to 5 in increments of 0.2 and then calculated y1 based on the equation. 2 points. Using the same x, create vectors based on the following. Put all 3 of them on the same xy graph. 2 points for all that? Well, that's a lot of work for only 2 points. So y2 equals 7 times the cosine of 3 times x. Y3 equals 3 times the cosine of, where'd it go? It's hiding. You kumquat. Oh, just x. Okay, we're gonna suppress those, and then we're going to plot all three results on the same xy graph. So we're gonna do a plot, and we'll do x, y1, x, y2, x, y3. I hope I got all my commas and everything in the right plot, and that should give us a nice pretty plot with 3 lines on it. Should. Where'd my lines go? There it is. Pretty rough because there's not a whole lot of data points on the x. If the x was more than 0.2, it would be a much smoother line. Okay. Okay, so the first line should be blue with solid line and circles for markers. So I'm just going to come up here and edit this. It should be blue. Blue. I think blue is B, and circles. There we go. This should be a solid line with blue. There we go. Right, it said should be a solid line and circles for markers and blue. So okay, cool, we got that one right. Okay, so the next one should be red dashed line and squares for the markers. Oh, I forget the squares. So this is where the online help in here helps out. So we just do a help, no P in help, the plot. Oh, and there's no K in help either. I tell you, you guys hang out with me long enough, I'll teach you a lot about spelling. So we come up here, and right here gives us our colors and all of the formatting stuff for. And I increased the font size so y'all could see it, so it's making it hard to see or get it all on the screen here. Okay, so we are supposed to be a solid dashed line with squares. So number 2 is going to be a solid dashed line. Is 2 of those. What color was that? I tell you, having only 2 functioning brain cells, you tend to forget a lot. Red with squares. Where are squares? Squares and S. And then the third line should be black with dotted line and asterisks for markers. So it's going to be a comma. Black is K. Oops. Dotted line is a colon, and asterisks is probably the asterisks. Not an octothorpe, you idiot. Hey, that's not nice to call me names. And then we do a run, and look at that. Everybody's nice and pretty and hunky and dory, just like the problem asked for. Okay, include a title, label, grid, and a legend. Okay, well, we can minimize this guy here. We don't need you no more. So let's come back up here. Add a title. And it's going to be, we'll just call it a trig plot. X label is going to be, let's do something weird, like maybe, I don't know, let's call it X. Wow. Cool. Y label we'll call, okay, we'll call it f of x. There we go, because we got 3 different equations. And then we'll do a legend. um, um, let's see. Oh, is that? Oh man, it's been a while since I've done a legend. Okay, let's. The first one was what? What was that? What was that equation? 7 sine 4x. Where to go? 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 Oh, there it is. Um, I'm, um, um, I guess we'll find out here in a minute if I did it right or not. And then the second one was 7 cosine 3x. 7 cosine 3x. Oops. And the last one was, I think, just a 3 cosine x. 3 cosine x. And did it work? Oh, you forgot one thing, though. You forgot one thing. Variable x. What? Oh, because you cleared everything out, you idiot. Where did my plot go? Somebody stole my plot. Oh, there it is. Yay, it worked. But we forgot one thing. A grid. We forgot to grid it. So we'll just add that down here. Where is? Oh, there it is. We'll just add grid on. Okay. So that's a lot of work for 10 points. How do I get the parentheses to pop up? That's just a feature. I'm running, this is MATLAB 2018B, and it's also a feature of the live editor. It won't do that in an M file. If you're, you know, like it did here, see, it even if you spelled it right, it still wouldn't work. It won't pop up automatically, but in the live editor, it will. When I did the first one, the second one popped up. When we do cosine 3x, we don't have to do, even though it's in a matrix. The only place I didn't use a matrix between the coefficient and is down here in the legend. But up here in my calculations, I did. Oh, the dot. Yeah, no, the dot only time you need to use the element operator is if you're doing vectors of the same size and you're trying to multiply element by element. But if it's a scalar value, you don't need to. You can. It'll still work if you put the dot in there. It'll do the same thing, but that's 2 extra keystrokes that I have to make, and you know, I'm super lazy. Perfect. Any more questions? I like questions, especially ones I know the answers to. Okay, you guys can't see it, but I'm dancing here in my chair. Okay, problem number 6. I'll move on if there's no more questions. Okay. Oh, anonymous functions. We like anonymous functions. Create an anonymous function called cubic function equal to that mess. So we're going to call cubic function, and we get this by doing an @ sign and our variable in parentheses and then our equation. Again, I don't like doing a lot of extra keystrokes, so I'll just copy and paste and put in my asterisks where they need to be put. And if we want to make it so that this is good for vector input, we'll just do a dot on those powers. Okay. Oh, good thing we did. Okay, fplot. Let's make sure I get this right. Okay, so we're going to do an fplot of our function. cubic. There's no I. Well, there is an I, but it's in the wrong spot. Cubic function. And we're going to go from minus 10. I think is this in square brackets? Caramba. 210. Let's see what kind of a plot we get. Oh, look at that. It worked. Yay, he did it. I'm so impressed. Oh, you should be. Oh, titles and labels. Okay, so we got to do a title and label. Okay, so we'll do a title with two T's is a cubic function with single quotation marks. Makes it more happier. Labels, X label is going to be, let's do something weird like, I don't know, X again. Yeah, it's always a good thing to do. Y label this time. Whoa, dude. If we wanted, we could be really nasty and come up here and grab this and make that our Y label. Hey, go away. And did it tell us to do nope. Okay, and then we'll run that and see what it does. Oh, it doesn't do nothing when you can't spell label right. I are an engine manure, not an English major, so anytime my kids ask me, Dad, how do you spell this? I tell them, well, there's a silent Q in there somewhere. Okay, so part C for 5 points. Use the fmin bound function to find the minimum function value in this range. If you do not recall how to use the fmin bound, use MATLAB's help functionality for guidance. So we'll just type in the fmin bound and we'll give it our function name, followed by the limits on the function. And there's our minimum answer. And I questioned this when the guy wrote the test, but I don't know. I guess it's finding the minimum place where it crosses the x-axis is right here. That was a different problem I was questioning, not this one. So yeah, the minimum place where it crosses the x-axis is down here at 3.66666666666666666667. Problem number 7, anyway. Any questions on problem number 6? Anonymous function is just, this is what makes it an anonymous function right here. Is the @ sign followed by your variables in the function inside of parentheses. This is chapter 6 stuff here. Problem number 7, 5 points. Create MATLAB function called called mice sign that accepts the angle. Okay, so when you're using the live editor, you do not create another M file. Okay, I just copied that. Oh, wrong button. I'll just hang up on them. They can call back if it's important. You come down here to the end of the file and do functions down here. So we're going to create a function that accepts angles as an input and calculates hyperbolic sine value x. Okay, so it's going to have a result. Okay, and we're just going to assign the results to a variable called results. Okay, we could call that anything we wanted. We could call it Chahasahulahiki, but odds are I'd misspell it every time I tried to use it. Results I can almost spell right every time. The name of this function is my sine hx for hyperbolic sine, and it is going to have one input that is an x. So there's the very first line. Now, I don't know if y'all are aware of this, if it learned it or not, but all this code that's right here in quotation or comments after the function sign, whenever you type help over here, MATLAB will return these comments as your help. Okay, that's just an FYI. Okay, so it's going to return to results the value of exp of x minus the exp of negative x. And I think both of those are supposed to be divided. I think it correct me if I'm wrong, but aren't both of those divided by 2, or is it just the last one that's divided by 2? I don't know. I should know that. Oh yeah, and you should always end your functions with an end. Hang on, I'm just trying to find my solutions to this to see if that was done correctly. Because I are an idiot with a girl named Bridget who does a lot of fidgets. My solutions. Let's see, that was what. See, the beauty thing is I can edit this out before I post it to everybody who didn't show up for this, so you guys are privileged to know that, hey, the teacher didn't know what he was doing. Okay, so fall 2017. There we go. Yeah, see, it is divided by 2. I was right. The computer was wrong. Let's see, and it's things like that that make students really crazy, because they'll sit and they'll wonder, okay, is this supposed to be this, or is it the whole thing? And it's just, okay, yeah, it's not necessarily MATLAB code, but it doesn't mean that I know what it's supposed to be. Okay, I digress. No, hi there. Okay, so part A, I've created the mathematical function. Okay, done. I'm going to be posting this on my solutions with a blank copy of the exam with the video. I'll have it up tomorrow, so that's why I'm putting all this other stuff in there in case you're curious. Okay, use your function part A to plot within the range of -2 to 2. Don't forget the appropriate annotation. In the future, we will not remind you that all graphs should be included. Points will be deducted if you fail to add them. In the future, what? There's only 2 problems left. Okay. I guess that means part test 2 in the final. Okay, so we're going to have a range. So we're going to have x equals -2, and let's make this a smooth plot. Let's go by 0.001. Make a lot of data points. Make that sucker really smooth. Y is going to be, what did we call that? Oh, my sine x of x, and we'll suppress that. And then let's do a plot of x and y, and it didn't ask for any colors or anything nasty funny. So this is going to be, let's see, an x label. Again, let's use that. We've been so friendly with that guy so much. Let's do him again. And another y label, and this is going to be sine x. Oh, and let's do the single quotation marks. And title. Oh yeah, let's see, I keep forgetting. Let's do the clear up here. We probably should have cleared up here too. Hey, that wasn't nice. Okay, where are we? Beater deeter deeterned. Beater deeterned. Okay, title equals title. I don't know. My function. It doesn't have to be anything spectacular. Bad to the bone. Why are you guys bothering me so much? Oh, somebody's at the door. Okay. Where's my plot? Is there a problem down here? Why didn't it plot it? It should have plotted. There it is. And there's my plot. Okay. Any questions on the user-defined functions? Okay. Problem number 8. Using imaginary numbers. So it wants to find the magnitude and angle of x, y. So again, I think this is the first time in all the years that I've been teaching this class, when we gave this exam, that there was ever a problem using imaginary numbers on the exam. So if there is by chance one on there, to get the magnitude, you just multiply the two angles together. Oh, you got to define them first, stupid. I knew that, but I was just seeing if you guys are paying attention. You multiply them together. That'll give you the angle. So let's define them. The easiest way is to just define it the way it's written. Whenever you use the lowercase I, it takes it as an imaginary number. Oops, gotta have this equal sign. 10 minus 5i. So those are now two imaginary numbers. So absolute value will give you that, and then if we use angle of x times y, why are you doing x times y? Because it asks for it right here, x times y. And so there is the solution to that. The magnitude is 105 units and minus 0.25 radians. Questions, comments, wants, needs, desires, concerns, complaints? Complaints, yeah, I want to complain. Look at that, problem number 9. 20 points? Really? Okay, well, we give you half. Oh, look at that. Looks like we gave you all of it. Wow, that's not fair. Okay, well, we'll delete all this so that I wonder if we did that on the exam. Wow, I bet the students really loved that. 20 points free. Wow, cool. Hey, that's neat. Do that every time. Yeah, okay. Okay, create a mesh surface and contour plots for the function z equals exponential of y plus iy for the interval -1 to 1 and -2 to 2 pi. In each case, plot the real part of z versus x and y. Okay, to do this, okay, so we'll create our vectors of x and y, and let's see, so x is going to be from -1 to 1. Let's do linspace, only because that's the way it was up there before. Yeah, okay, I see that. Wrong one. So our beginning variable value is -1, the value is 1, and let's do 100 elements, and we'll suppress the output. Oh, look at that, it says right there, create a vector with 100 evenly spaced ones. Okay, and y with 150 evenly spaced ones. See, I told you I was doing it right, and you didn't believe me. Okay, so we're going to go from -2 times pi to 2 times pi with 150 elements. And let's suppress that. Okay, so now they're different sizes. We got to make them the same size so that we can calculate z. See, it says right here you must use the mesh grid function to solve this problem. So let's see, we can do all kinds of different things here, but we'll go ahead and do we'll do two new variables, x and y capitalized, which are different than the lowercase y's. We'll go mesh grid, and the only thing mesh grid does is it takes two variables of different sizes and creates two matrices of the same size. So two vectors of different sizes, it creates two matrices of the same size. Then you can multiply them together using the element operator in your calculations. So now the equation is exp of x. We've got to use a capital X because that's the new one, plus I times y. And there's our z. And let's see if we get any errors. Oh, no errors, so that's good. We're good to that point. Did we use a clear up here? No. There you go. Don't use that clear again. Oh man, I tell you, I get really loopy. Or is it really doopy? I don't know. Okay, 10 points. Display all three graphs on the same figure using subplots. The figure should have 3 rows and 1 column and should appropriately be labeled. On the surface plot, issue the shading interp command to remove the grid lines and create smooth shading. Okay, so the plots we're supposed to create are mesh, surface, and contour. So, and we'll do, okay, so the first thing we do is we call up our subplot, tell it where we want to do it. Okay, so it wants 3 rows and 1 column, and then this will be the first plot in that. Then we are going to mesh x, y, and then up here somewhere I remember to see right here the real part of z. So then we'll come in here and say we just want the real parts of z. Hopefully there isn't something like that on the exam, because I don't remember anything like that being in the homework. So this is the mesh plot. X, there's no W in label, serious. Even I know that one. Should we really confuse everybody and call it Y? Oh no, okay, we'll call it X. Y label, Y. But I'll tell you, okay, at least for my class, I don't know if other classes will be viewing this video, but whenever I grade an exam, I take the exam first, and if there are any parts of that exam where I struggle, I don't expect my students to be able to do it. I mean, if I can't do it, how can my students do it? Like a problem like this one here, I would have struggled a little bit. I mean, I got familiar with the real Z because it was only a year and a half ago, but so I'd give, I mean, if you make a half-hearted attempt, you still get full credit for the problem. So I guess that's good for tests that other instructors write, but then, if I'm writing my own exams, I don't like writing tests. I'd much rather take one than write one. Subplot. Okay, so this is going to be our second plot, and it's still 2 rows, 1 column, but this is plot number 2. And let's see, we were doing the surf. Again, X, Y, and the real part of Z. And we're just going to borrow all this stuff down here, except change this to a surf. And then finally we want to do a subplot plot, 3 rows, 1 column, and a third plot. And this one is going to be contour. Too many O's. Use contour. Again, the X, the Y, and the real Z. We'll borrow again. Contour plot. Only this time here we got to add another command up here because it wants the shading interp. We'll just borrow that as long as we got it and bring it down here. And there we have the final problem. And hopefully we get a nice pretty plot. 3 figures. Ooh, look, wavy lines. Dark, cool. Okay, so that's the end of that exam. Are there any questions whatsoever? I mean, I know I went through it quite a bit. I got off topic quite a bit. I think this test here was the longest test that we've done. Usually we try to keep it around 7 or 8 problems. But again, I'm not writing exam number 1 unless I don't hear from the other professor before Sunday. Then I'll quickly write one up for Monday. It may have 2 or 3 problems if I'm writing it on Sunday. I know. What's your name? Okay, cool. You passed. I will post this exam blank with the solutions with the video. I will also post, well, there is another exam that came out in an announcement earlier. However, there were no solutions to that. I will post the solutions to that one. So that'll give you a couple of practice ones to go through before you take the exam next week. Holy cow, 50